Today we are going to discuss about FinFET. It's an advanced MOSFET. This is acting like a MOSFET, but the structure is different. Usually in the MOSFET, we have only one gate. Between source and drain, there is only one gate. But in the FinFET, we have multiple gates. So we can control the channel using multiple gates. So if I have only two gate active, it's called double gate, DG structure. So between source and drain, there will be two gate controlling the channel. So in that situation, we can even control the threshold voltage. So since there is two gate, we can fix one gate to decide the threshold voltage level, and the other gate will control the current flow. So here is a simple structure of the FinFET, though it is not that attractive. We do have two things. One is the source, another is a drain. So this one is the source, and this side, this is the drain. On top of source and drain, it's an insulating film. So though we have a gate on top of it, but that gate does not useful because it is not touching the source and drain. But the vertical two gate, this is the U-shaped gate. U-shaped gate. This and then the between source and drain is the channel. So this is the gate. Gate is like U-shaped. It's vertical from that side, and then flat on top of it, and then again vertical in the front side. So if we can, it is in this FinFET we are using a two gate. One gate in the front, another gate in the back, and the top gate we are not using. If there is no insulating film here, then we will have a tri-gate, gate 1, gate 2, on the back side gate 3. Since this source and drain, in between is the channel. So if I have this is fin-like structure. Why it is fin-like structure? Because we have multiple gate like this. This is the gate, polysilicon gate, and then this gate is overlapping this fin and then this fin. So there are two fin here. These two fin are separated. So if I want to make a one common transistor, then I have to have a common drain in this side, connecting these two fin, and then common source in this side, connecting these two fin. So as many fin as we need, we can connect using another big source and the drain in both sides. So here the anatomy of this structure is that under the fin there is a stopper so that the leakage current cannot go to the body. Usually it is a silicon carbon ratio, some film is called PTS to stop leakage, and the bottom one is the substrate. And between fin, like if I have two fin, between fin we use, this is the insulator, element isolator. Element isolator means isolating fin from each other. And so that's all in the anatomy. So this is only one single fin. So if I um, fabricate transistor with multiple fin, then we add these fins with a bigger source and drain. So if I take the vertical section, so this is gate 1, this is gate 2, and the top one also we could use as a gate, but here we did not use it for third gate, so we did not use it, and the whole thing is like U shape. And then if there is another fin here, then this U shape will be again here touching each other. So the top, this gate will be top line. Irfan, তোমারটা mute করে দাও. And this is the channel. The channel is not in doping condition. Drain and source is in either N doping or P doping, P type or N type. And this hazard line is the gate oxide. This one is to stop, isolator, element isolator, fin isolator. This one is the body, and in the bottom of the fin, we have a by ion implantation, we make a silicon carbon stopper. So the leakage current cannot go to the body. So that's why the performance is good. So in this channel, we form two channels, one channel with this gate, another channel with this gate. So the current flow increases. So if you want to see another step here, this is the advantage of the fin. Feature size is getting smaller and smaller, and power loss is very low, at 150% improvement. Operating voltage we can lower it down, threshold voltage we can control, and then the speed 30% faster, and leakage almost zero, 90% reduced. So here it is. This is the gate. This is dual gate. This is one gate this side, and then the other is on that side. And so this one is the source, one face of the source, and the back side, and that one is the drain. So just the fin part is shown here. This is the gate length, channel length, and this is the channel width. So we usually cannot change the channel width that much. If I want to increase the channel width, so what I do, we use another fin. Say I need channel width of 25 micron, then I will have a one fin of 25 micron. Then if I need a 50 micron width, then I will use another 25 micron fin. So the two fin added will be 50 micron width. And this is the gate length, which is like a process technology. If it is a 7 nanometer, then this gate length will be 7 nanometer. From source to drain, this in between, that part will be 7 nanometer. So here is multi-fin. Here is 3 fin together, forming one transistor. This bottom part here, this is source, and the other side is sink. But this silicon substrate, this is the body. So usually there is a stopper here. The stopper is here. So the stopper is here in this place. Stopper is here. So this is just supporting the body, but it's not connected to the body. And to connect these 3 fin together, we should have a common source in this side, and similarly common drain on that side. So I don't have the full picture of one transistor. Okay, here we have two types of FinFET. One is the bulk and it is the SOI. Bulk and SOI to process. In SOI, this stopper uh, is a epitaxial layer on top of the substrate in SOI. But in the bulk, we just every channel we create this stopper. So this is the main difference between the bulk type and then the SOI type. So next, so we will discuss about the how to form a SOI fin, and then we'll discuss how to form a bulk fin. For SOI fin, SOI wafer preparation. SOI wafer preparation means we have the wafer, on top of it we have a insulation layer, and then on top of the insulation layer we gradually will create the source, drain, then gate, and then fin. All this structure will be developed on top of the insulation. So after SOI we do the channel doping. How we do doping? By diffusion or ion implementation. Then hard mask Si deposition. We want to transfer uh, the fin structure. So before we transfer the fin structure, we do have a mask, silicon nitride mask. So then after that, fin patterning by SWT process. This is sidewall technologies, the sidewall transfer. So this technology we will discuss. We haven't studied SWT, but here the deposition we know how to do deposition. Then plasma nitride gas oxide formation. So the this is by oxidation. Uh, we form the oxide around the fin. Then polysilicon deposition and planarization. So on top of this, we gate poly. We deposit the gate poly, and then we make planar. Then gate patterning by SWT process. Since the fin is done with the SWT, then we also do the gate, that also with the SWT. This is SWT because uh, the gate is not planar, it is vertical. That's why we need to do another new process. It's called SWT. Then selective gate sidewall spacer formation. This one is for multiple fin. If I have a one fin, I don't need this spacer. But if I have multiple fin, then I need to have the spacer. Then elevated source and drain extension formation with selective SI epitaxy. Epitaxial source and drain. So this one is the fin. This one is the fin, but is this big one? This is uh, source and drain. So this source and drain is done with the epitaxial process. So the source and drain extension formation with selective SI epitaxy. We know what is epitaxy. Then source drain extension, ion implantation tilted at an angle 30 degree. So for doping, after epitaxy, we do the doping. We do the doping not with the diffusion, we do it with the ion implantation. TOS or SIN, gate sidewall space formation. This one is this part, this oxide special. This oxide is formed by TOS. TOS, whether you know remember it, it is a CVD. In CVD, we know how to develop oxide. So the sidewall is done, separation, space formation is done with the CVD. Source and drain implantation and activation. So source and drain, if we need more implantation for the carrier concentration, we do implantation. And when we do implantation, we need to have do the activation by annealing. Annealing, we do the activation. So when the source and drain is done, now I need to connect with the connector or the interconnect metallization. So to connect this with the metallization, we need to make a contact. So a nickel silicidation. We form the nickel silicidation to form the contact. Since this since this transistor are very tiny, so we have to have a good contact because our contacts are also tiny. So low resistive, and the nickel silicidation is a very good for low resistance contact. So now here most of the process we have studied except SWT. The SWT is the one which form the fin. So there are four ways to form the fin. Four process. One is the SWT, sidewall space transfer. Another SIT, another sidewall image transfer. Another SADP, a self-aligned double patterning. Another spacer lithography. There are four of them. So what actually does, let me see what's in here. This is not given here. How we make the fin, it didn't show here. We started with the fin, already fin is there. So let me check here. How we are forming the fin. This is the bulk process. There are two ways. One is the SY, another is the bulk. Here, how the fin is forming is showing here. So here we give a hard mask and then the resist, and then we from the resist we form the hard mask here, and then we remove the resist. After removing the resist, keeping the hard mask, we etch from both sides and then in the middle, and the fin form. Here the fin form. So after the fin is formed, then we cover with this oxide, so that uh, this one is the one side of the gate, and this one is the another side of the gate. So we need to have that gate oxide here. So then we put this gate oxide here, then we keep it like this, then we form gate oxide again. This gate oxide is done with the deposition. We get the gate oxide. So that's how we form the fin. After the fin is formed, then we deposit the gate on top of it. Then we get that. So here it's on the bulk how we make the fin we discussed. There is another let's see where it is. I have loaded all this for you here, the fin design. So here is this fin design. Here it's called double exposure or double patterning or spacer double patterning. So I need to make the fin like this. The bottom one. This is the fin width. I need to make this dimensional fin. So in this process, what we do? We do exposure twice. Lithography exposure. First, we make this mask. This mask, uh, the size is double. Whatever pattern we want to generate, we keep the double size, and then from this mask we generate half of the twice size of the fin, and then we bring another mask which is also double size. Then we expose it, and we get the right size of the fin or double patterning. This one is we here we have only one resist, one layer of resist, but here we have two layer of resist. There is hard mask, develop layer, and the substrate. We will make it on there, but here is no hard mask. So this one is double patterning. So in the first pattern, we get this one, and the second pattern we get this one. So double patterning actually, and since the pin are very small in size, so with the lithography we might not be able to, in one shot, we cannot transfer the size. That's why we take the double size and then expose it twice, then we get it laser. Or we can do it with the spacer, or the size is there, but the space is double. Space is double. So that's why there are three ways. One is the space double, another is the size is double. So that's why here uh, sidewall space transfer means the space is double. A sidewall image transfer means the pattern is double. Self-aligned double patterning, uh, this one type of image transfer. Double patterning, the size of the pattern is double. So these are different technique, four technique to develop the fin. Next we discuss about the bulk substrate. In the bulk substrate, what we do, first we form the fin, then fin trimming, oxidation, so oxide removal from the fin and the fin cap, then HDP, silicon dioxide fill, and CMP. This is the process. The thing I written there, only the points where it is explained over here. Then we do each back of the HDP silicon dioxide, and then punch through stopper PTS by ion implantation. This part here, we not here, here, just below the gate. Gate is up to here gate. So here we make the PTS by ion implantation so that it uh, does not have leakage to the body. Then after ion implantation, we do annealing for activation, then gate stack formation, then offset special formation. Offset special formation. This is the spacer. And then source and drain extension. From the fin, we have extension of source and drain, and then we doping we do with the ion implantation. Then gate sidewall formation. This means from gate to gate the sidewall, and then source drain ion implantation, and then activation annealing, then silication for contact, then metallization for interconnect. These are the process. So here also this fin formation, we need to go through this four process, one of the four process, either SWT or SIT, SADP, or spatial lithography. So in this FinFET structure, you don't need to explain all this process. We just mention the processes we use. We can ask about like how you form the fin. So more important here is these four things. SWT, what is SWT? We have explain SWT or SIT, SADP, these things. Here I did with hand drawing, which I have shown here. So step by step, I did it over here with the hand drawing. So these are the same stuff, how to transfer the fin or how to form the fin. So that's all today for the FinFET. And next let's see what we have. Here the SY FinFET process, how we from the fin, then you cover with the gate, and then you CMP, chemical and mechanical planarization. Then you make it plain, and then on top of the gate you put a resist here, and then also silicon nitride stopper, and from there you take up the silicon, shape the silicon nitride here, take out the resist and the silicon nitride from here. The silicon nitride of this bottom of this resist will remain, and this one from here we do the etching of the gate oxide, total gate. Then we get the gate formation, and then when the gate formation is done, then we take off the silicon nitride, and then between fin we put the white one. This is the spacer, gate spacer oxide we form. So that's how the SY film is done. The whole box, this box is what is called the insulator, and then the bulk is below this one. But in the bulk FinFET, we have this bulk, then we form the fin on top of it, and then we take off the body of the silicon, and then we cover it with the isolation. Isolation is the shallow trench isolation. So we form the oxide here, and then on top of it we cover with the oxide, gate oxide, and then we trim the gate oxide. So we form the gate oxide here, and then from both sides of the gate oxide we put the spacer. So in the bulk, and then that one we trimming the bulk here, resizing the bulk here to form the fin. Over there, the fin, the bottom part, this box, we are not touching the box. So in SY, everything is done on top of the insulation. In the bulk system, bulk process, we take form the fin on the bulk. So these are the two major difference between the bulk FinFET and then the SY FinFET. So today, and so we are going to discuss about the future of this transistor. What transistors are coming after that? What's after FinFET? So we have only this pin. If you understand from here, this is the pin, and this is the gate covering. So this is one side, this one gate, and the other side is the other gate. So this one is going from this side to the that side. In between is the channel. This red part, the purple part is the channel, and this one is source, and back side is the drain. So we have only one pin here. If we need multiple pin, we usually put on the right side or left side of this pin other pins to increase the current flow. But there is another vision coming for future, that can we divide this pin into square shape and then make the gate all around. So this one is like it's called the round the square, round or square wire. So each one is a channel, separate channel, and then each channel is covered with gate around it. Each channel is covered with gate around it. And also they found that instead of making it round, if we make it horizontal, uh, like a not square, rectangular shape, then its performance or um, fabrication is easier than this one. These are not fabricated yet. These are the vision, thinking about it, how to make multiple gate or multiple wire as a gate, fin gate. So each one will have 4 gates. One is the top, another is in the bottom, another is the right side, another left side. So it will be gate all around, GAA, gate all around. So but the cost is very high. Whereas the conventional is take each transistor 24, uh, it takes 225. So these are the future goal or future idea. This is the planar, the source, drain, and then the plain gate. Then it comes the FinFET. So it is a multiple fin, but all the fin are vertical. Then here comes the narrow nanowire as a multiple round shape or the square shape fin. And then also we can do it with the vertical type of fin. Also, it is coming with uh, both combination. So how would the transistor look like? And then this is the 2-gate pin. This is the wire dot wire pin, and this one is the sheet pin, nano sheet. This is nano wire, and this is nano sheet. That's what will look like. Here the source, and here is the drain, and this is the pin. And this pin will have a vertically nano wire stack 5x, 5 of them, 2, 4, 5. So this is called gate all around control structure. So this is the gate. So this one, so if we can control, we have multiple gate for one single transistor. So we can control one single transistor with the different gate controller. So here all the gate is connected together. We could have separate connection, separate controller. So the future transistor is going to look like this. There will be a channel, several channel uh, between source and drain. If you want to increase the width, nowadays what do we do? Our process, if it is a 7 nanometer process, then the channel length is 7. So if we want to make a bigger transistor, what do we do? Our channels stay same 7 nanometer, but we increase the width. So increasing the width, we make a bigger transistor. Here, instead of increasing the width, we will be increasing the number of nanowire, number of gate. So that's how the future transistor is going to be. So what will happen? It is going to be a vertically uh, increasing. So our area will uh, we can accommodate more transistor in the same area. So this is a kind of a future vision. So that's all for today. Do you have any question, Irfan? So ফিনফেট নিয়ে তো তোমরা এই জিনিসগুলো একটু দেখবা। এখানে ফিনফেটের যেমন খুব বেশি ডেপথে যাওয়া হবে না, হয়তো বলা হবে যে ফিনফেট তৈরি করতে কি কি প্রসেস গুলা লাগে, এর মধ্যে থেকে হয়তো এই প্রসেস গুলো সম্বন্ধে জিজ্ঞেস করা হতে পারে, এসডব্লিউটি, এসআইটি, এটা। আর এসওয়াই কে কিভাবে করা হয়, এসওয়াই আর বাল্কের মধ্যে পার্থক্যটা কি, কিভাবে করা হয়, ওই জন্য হয়তো ওইটা নাই আর এখানে। ওই যে এসওয়াই বাল্কের একটা ছবি দেখেছিলাম না, ওইটা ওই দুইটার কম্পারিজন, দুইটার ছবি বলে দিতে পারো যে এসওয়াই তে আমাদের বক্সের নিচে কোনো কাজ করা হয় না, কিন্তু বাল্কের মধ্যেই শেপ করে আমাদেরকে ফিনগুলাকে তৈরি করা হয়। সো দ্যাটস অল ফর টুডে। তো তোমরা এগুলো দেখো আরো, হ্যাঁ, অনেকগুলো মেটেরিয়াল দিছি, এগুলো একবার রিডিং করলেই বুঝতে পারবা। আর তো তোমাদের যদি কোশ্চেন না থাকে এখানে শেষ করে দিই আজকে। মইনুল কিছু বলতেছ?
না স্যার।
আচ্ছা, আজকে এখানে শেষ করে দিই তাহলে, হ্যাঁ। আর নেক্সট উইকে কোনো ক্লাস নেবো না আমি, ক্লাস নিলে ঈদের পরে, নেক্সট উইকে কোনো ক্লাস হবে না। আর তোমাদের যদি কোনো কিছু জানতে ইচ্ছা করে বা এক্সপ্লেনেশনের দরকার মনে করো, তাহলে ওই ইমেইলে আমাকে যোগাযোগ করো, তাহলে আমি আবার হয়তো একটা স্পেসিফিক একটা ক্লাস তোমাদের জন্য করবো, অ্যাসাইন করবো, ওই ক্লাসের মধ্যে আমরা আলোচনা করতে পারবো।
ঈদের পরে স্যার কয়টা ক্লাস হবে স্যার?
এদের পরে আমার তো মোটামুটি কোর্স শেষ, এখন তোমাদের প্রয়োজন অনুযায়ী ক্লাস করবে, ঠিক আছে? তো এখানে শেষ করি তাহলে।
জি স্যার।
ওকে, রেকর্ডিং বন্ধ করুন।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।